Welcome to Module 4, Impacts of Aquatic Invasive Species. Now we understand how non-native species get here, how they become invasive once they start causing problems or show potential to cause problems, and all the challenges they face along the way to becoming an invasive species. In this module, we'll take it a step further. We'll learn the impacts and effects of aquatic invasive species on you, the economy, the environment, and other organisms. In general, impacts of invasive species are difficult to measure. Assumptions, stories, and the media often distort the facts. You really need data from before the presence of the invasive species to truly describe and measure the impacts. Some impacts are easily noticed, like those of the Burmese python in the Everglades or the lionfish on Florida's reefs. These invasive species are predating on native species at a very high rate, decreasing prey abundance and diversity. For example, in the Everglades, raccoon populations have declined 99.3%, possums 98.9%, and bobcats 87.5% from 1997 to 2012. Rabbits and foxes disappeared as well, and these mammals have all been found in the stomachs of captured Burmese pythons. Impacts can be biological, economic, or social. Biological impacts include predation, competition, carrying a disease, changing the genetic information of another individual or population, and changing the area others live in. Economic impacts include property and public utility damage. Jobs related to fisheries, the aquarium and pet trades, aquaculture, food, plant nurseries, shipping, and real estate are also impacted. Market prices, especially the price of food, bait, and ornamentals are impacted. Social impacts include changes in regulations pertaining to invasive species possession and transport, opinions about invasive species, and human health. Invasive species can cause losses of natural fish and stocked fish populations, the number of different native species, the number of individuals in a population, the ability to breed and pass on healthy genes, and habitat structure. Additionally, due to their negative impacts and potential threats, new policies have to be created to protect public health and the environment. But they also put restrictions on trade and shipping that impact the economy, people's livelihoods, and hobbies. They can potentially reduce the quality of life or property value if the invasive species brings in a disease, causes damage to your property, ruins the beauty of your waterfront view, or makes recreation on or in the water difficult. In the state of Florida alone, aquatic invasive species cost millions of dollars each year trying to control them, especially plants. You have to keep on them because it's usually not a one-and-done type of treatment or control effort. Despite the negative effects from invasive species we've learned so far, there are a handful of benefits from non-native species. Aquaculture, which is the farming of aquatic organisms, produces fish, plants, corals, sponges, live rock, baitfish, and more than half of the seafood we eat. Florida's aquaculture industry consists mainly of non-native species and brings in over $172 million in sales of tropical fish alone. Aquaculture also produces the fish agencies use for stocking. Some non-native fish, such as the butterfly peacock bass in South Florida, make for a thrilling fight that attracts people to target them. Grass carp, a non-native to Florida, are produced as sterile and stocked in a controlled manner to eat nuisance weeds and water bodies. Also, many non-native plant species are beautiful and make ponds in our yards look prettier. Here's an interesting example of an invasive species helping an endangered native species make a comeback. Snail kites are raptors, native to Florida, that live in marshy wet areas, historically those of the Everglades. They nest in trees above the water, and their favorite food is the native apple snail. When the Everglades were drained and rerouted, the native apple snail numbers declined from loss of habitat and water quality. And then the snail kite population plummeted too. They were losing their habitat and their food source. Eventually, the snail kite was listed as endangered in 1967 due to their low numbers. They needed extra protection and help. In the early 2000s, when the invasive island apple snail was introduced and exploded throughout South Florida, the snail kite started eating them. They are quite similar to the native apple snail and make a decent replacement snail for food. An added bonus is the invasive apple snail feeds on hydrilla, an invasive plant that was introduced in the 1950s that thrives in marshes and lakes where the snailkites live. The invasive hydrilla provides food for the invasive apple snail, and the invasive apple snail provides food for the endangered native snailkite. At one time, their population was fewer than 800 birds, and now they're estimated above 3,000 birds. Let's discuss hydrilla a little deeper. Hydrilla is native to India, and it was introduced to Florida in the 1950s as an aquarium plant. It escaped a cage setup in a canal, thrived, took off with the help of humans and the connectivity of water bodies in Florida, and the rest is history. By the 1970s, it was established throughout most of Florida's freshwater systems. The hydrilla plant we have in Florida is only the female plant. It reproduces through the use of tubers, turions, and fragmentation. Fragmentation is when a part of the plant breaks off and is able to grow a new plant from that piece. Fragmentation allows hydrilla to multiply quickly while also having a backup plan of tubers and turions hiding dormant in the bottom sediment for years to come. It also grows fast, up to 20 feet long, creates massive mats, and takes most of the sunlight and oxygen for itself. It leaves little for other submerged aquatic plants and animals, which is not healthy for the habitat. The dense mats create stagnant water conditions, which warms the water, raises the water level from so much plant biomass, doesn't allow for much mixing of the air and water, and what likes stagnant water? Mosquitoes. As a result, millions of dollars are spent annually trying to control hydrilla. There are pros and cons of hydrilla, so it matters what your interests are. In terms of the ecosystem, it takes over and reduces native plant diversity and abundance that aquatic animals use and need in all stages of their life cycle. Entry into the water, around your docks, and where you want to wade into the water is difficult or unappealing. Swimming, snorkeling, diving, tubing, kayaking, paddleboarding, boating, fishing, and even photography and birding become challenging with hydrilla growing dense up to the water surface. With enough hydrilla in areas where the water level is controlled for flood or navigation purposes, hydrilla can raise the water level and cause property damage. Aesthetically, it's not that pleasing to see the biofilm or scum that grows on the surface of hydrilla meadows. Waterfront property value and income are also affected due to these reasons. On the flip side, hydrilla is really good at clearing up turbid waters and can make great largemouth bass and duck habitat for anglers and duck hunters. Hydrilla isn't supported by everyone, but there are some user groups that strongly prefer it. There's great debate about how it should be managed because of the differing opinions by scientists and public user groups. Moving forward, what needs to happen? To separate fact from fiction, regular monitoring of water bodies needs to happen so data exists before an invasion, rather than starting monitoring because there is now currently an invasion. That would take a lot of time, money, staff, and effort. Risk assessments are something biologists do to understand a species and determine the level and nature of threat the species has here, if any. These are really important because biologists can potentially predict which species are going to be a problem in the future and advise others on preventing its introduction. This also helps with what's called early detection and rapid response. It's exactly how it sounds. Biologists have the knowledge to detect it early enough when it's first being introduced, and they can respond quickly to get rid of it before it spreads. Next, as strong storms like hurricanes and humans continue to change the land and waterscape, for example, by creating or destroying dams or creating canals and channels, these will continue to aid in the movement of aquatic invasive species. Climate change will bring changes in water levels, intrusion of salt water where fresh water usually is, habitat, water and air temperatures, precipitation amount and duration, diseases, seasonality, food availability, range change of species, and more variability overall. It's good to be aware of what we're up against so we can do our best to minimize our own actions that may help in the movement of aquatic invasive species. Lastly, education and outreach, public involvement, and school curriculum should be incorporated into invasive species management. Scientists cannot be everywhere all the time. We want to be able to rely on homeowners and other private citizens for recognizing a species that seems new to the area. We can start by incorporating invasive species into grade school curriculum while the children are young, and we can educate the adults at public events and through training and extension programs like these. If you'd like to learn more about impacts of invasive species, here are some good articles.